But I'm very excited that three of our very notable alumni are here to share their experiences, their journey, their advice and insights, all at the intersection of healthcare, data, and AI. So we're going to have each introduce themselves for a minute or two. We have Chris Soto Devetta, Erkin Oatlis, and Ranjani Ramamurthy. Chris, how about you introduce yourself first?
Hey everyone, Chris Scotto Devetta. I'm the Senior Vice President at Tempus AI. We are an AI-enabled precision medicine company at sort of the top line. And what that kind of means is if you're a cancer patient and you want to identify, we'll do a lab test that'll identify what's driving your cancer using a combination of lab science and AI, and identify what therapies would be best suited for your particular cancer type. And so it's a big data play. It's very biological and is also this deeply human service that we provide. I don't know if I'm supposed to give more of an intro than that.
That's perfect.
Perfect.
We got lots more questions. We'll circle back to some other ones. Ranjani, how about you introduce yourself?
Yeah, hello everyone. Delighted to be here. My name is Ranjani Ramamurthy. I have a background in computer sciences as well as medicine. So I went to med school almost a decade after I finished my computer science degree as well from the University of Wisconsin at Madison. Most recently, I'm vice president at Global Health Labs, which is an entity completely funded by Gates Ventures. I am working in the intersection of data and AI. I've done that for more than a decade now. We invest in devices and technologies with AI on the edge to improve primary care in low and middle income countries. So I'm a senior advisor to the Gates Foundation as well. Notably, about in 2020, I was general manager of the team that shipped the first AI co-pilot from physicians at Microsoft. So this was at a time when conversational intelligence is not understood as it is today. So delighted to be here. UW-Madison was one of the best times in my life. So super excited to be here.
Thank you. And last but not least, Erkin.
Hi, everyone. What a pleasure to be speaking with you today. So I'm a MD PhD. I style myself as a physician engineer. Not so long ago, at least I like to think not so long ago, I was sort of sitting in your guys' shoes as an undergraduate industrial engineering student. And that sort of led me down a path where I worked at Epic for a couple of years, saw sort of the opportunities available with all the health data that we had, and saw some of the stuff that was coming in terms of machine learning and artificial intelligence. Was very excited to build tools that would impact patient care. And that sort of led me into a little bit longer of a journey, but I ended up getting my MD PhD at the University of Michigan, where my PhD was in engineering. I built and deployed a bunch of different machine learning models that are in use in clinical care, and that sort of informed the things that I'm interested in terms of research and implementation, and eventually ended up back here at the University of Wisconsin as a resident physician in emergency medicine. I still do a good amount of research and then building tools that I use in my own clinical practice. And hopefully we'll talk a little bit about those and how they impact our care of the patients in the emergency department.
Great, thanks for those introductions. Erkin, you touched on your journey and the initial spark that started here at UW-Madison in healthcare and working for Epic. I guess a question for you to follow up with any additional information about how your time at UW-Madison helped nurture your interest in healthcare, and then we can have follow-ups with Chris and Ranjani.
I think it was really sort of formative, and I almost think of it as the seed that started everything. So I came in as a undergraduate, interested in engineering, still very interested in engineering. I view myself as an engineer, but not really sort of focused in any specific field. And I wasn't necessarily interested in becoming a physician, to be totally frank, at that time. But the industrial engineering department and College of Engineering sort of at large at the time, and still now to this day, had a focus on health systems engineering and improving the health of our population in Wisconsin and throughout the world. using engineering methods. And that really got me interested in thinking about, well, how do we actually use, the technical skills and the soft skills that we as engineers have to improve medical practice, operations, and then health at large. And so there were various research projects that I got tied into with faculty. There's Patty Brennan, Pascal Carrion, and then of course, Dr. Albert, who I worked with very closely. That got me sort of very excited about, the technical skills that we can bring, but then also sort of the softer side of things that we bring in terms of engineering systems and understanding how all the components come together. And really that lens, I think, opened my eyes into like what I could do as a physician engineer, and it gave me the courage to be able to sort of take those next steps into a world. Medicine is not necessarily a world that I feel incredibly comfortable in, but I do feel very comfortable bringing engineering to medicine. And that's given me sort of some courage to sort of go down this pathway.
Great, thank you.
Yeah, I'll go next. For me, I went to UW as a computer engineer. I remember I wanted to be an engineer because I wanted to solve problems. I thought healthcare, was an interesting place to bring technology. And I remember when I was trying to decide on my major, I just looked at sort of the salaries that you graduated with and picked computer engineering because it was the highest one. And then as I went on that journey, I thought UW did a nice job of showing you that just because you chose computer engineering didn't mean that you were sort of going to be bucketed into that space your entire part of your career, that actually you'd sort of decide on a mission, and on that mission, your engineering skills that you learned in computer engineering were like broadly applicable on like the thinking and processes to lots of problems. And so it gave me there's the co-op program that allowed me to go into industry early while I was still in school and get a feel for what industry was. I don't think a ton of universities do that. They usually do like a 3-month internship. I did 9 months at GE Healthcare. I learned a ton about med device. They kept me on after I was contributing to real work. And it was both the stuff I was learning in school, but also, when I mean stuff I learned in school, both what was in the textbook, but also just the thinking process that we were learning, and being able to just put that on problems. And so, being able to get exposed to industry so early, be able to get a feel for how to leverage what we were learning in books in the real world was transformative for me. And I've always sort of gravitated to that. Just want to solve cool problems. And UW, helped me understand that it isn't just about the label of the major on your ability to do that.
Yeah, my pathway into health data and health AI is a little more circuitous. So I did a master's in electrical engineering, PLSI design from the University of Wisconsin, and then went on to do a master's in computer sciences in database systems. And I worked in database systems for the next decade of my life. For me, I probably would have continued working in database systems, but I had a life event in 2004. My then 3-year-old got cancer. So she got acute lymphoblastic leukemia, and that changed the course of what I sought to do with my time professionally. So, for those of you who don't know, leukemia is the most common kind of cancer that gets cared, and it's almost 2.5 to 3.5 years of treatment. So once my daughter Leela had finished treatment, and she was one of the lucky ones, she's a healthy young lady today, I started really thinking about what I wanted to do with my life professionally. So a few years later, I left my job in the SQL Server division of Microsoft and started off at the bottom of the totem pole, doing pre-med as well as medical school, applied to one med school, the University of Washington, since I was raising 2 kids right here in Seattle, and went to med school. I was, I think, the second oldest student in class there. And when I was in med school, after my first year, I got introduced to a lab at the Hutch, at Fred Hutchinson Cancer Center, And I still work with them today, even in a different capacity, where they started sequencing the genome of kids. And I remember the first conversation I had with the PI, Dr. Sohail Meshanchi, and he said, Ranjani, I can get money to actually sequence the genome of kids, but I don't have the money to afford you. And I said, well, I come cheap right now because I'm a med student. And so that's when I started working in the intersection of data, genomics, and AI, and started putting the two things together. And and it was at a time when data is not the kind of platinum it is today. So this was 2012 or so. So anyway, what started then has what has continued to shape my career today. When I was finishing my MD, I got recruited by Microsoft Healthcare and was really, really privileged to be employee number one when we were looking at building an AI-assisted scribe for physicians. This was at the time when language models are not as robust as they are today. And in 2020, I shipped that product on Microsoft Teams. Landed up being extremely good product timing because if you all remember, that's when the pandemic hit us. So right when telemedicine started taking off, we had a product that we could ship for patients and providers. So that's kind of been my journey. And I think I credit Wisconsin with really giving me a very solid engineering as well as a computer science base. And setting me up for doing all of the work that I do in health data and health AI. I work mainly with data platforms globally now, and I've deployed AI at scale well before all of this started. So that's my journey. So a little different from my colleagues here on the call. So
Great. Thank you for sharing your journeys. And Ranjani, I'm glad to hear that your daughter is doing very well. You all made it sound very natural to find in your various journeys to find AI and healthcare with an engineering background. Did it at any time seem a little bit risky to go into healthcare, given it's not a traditional engineering application, although I think now it's getting to be a little bit traditional. Maybe you could weigh in on that.
I'm happy to go into that. It's a big risk. I went to med school at 39, when my career was going really well at Microsoft in the SQL Server division. And I kind of think of it as taking a bet on myself. And now, and since I've been, in that intersection of data and AI, I've always served as a translator and a bridge between disciplines. And it's always a risk to go into something where you're not, you're almost like a square peg in a round hole. And but somehow it seems to have worked.
Great.
Yeah, I'll just share. Quick thing. I talked to my software development or data scientists. It's like you can pick a lot of industries to work in. Your skills are transferable. One building something to solve a problem in another industry. Healthcare's got another level of expectations on what you build. And so you have to not only do the fun part, which is often, let's say build the model or build the product. You've got to navigate regulation. You have to navigate the fragmentation that often exists in the ecosystem. There also isn't like a clear buyer, the influencer of the decision maker and the person who can pay are often in different companies. And so you have to be a lot more thoughtful about your business model. So it's like an exponential challenge to be able to deliver tech-based solutions in healthcare. And so I think what's good is if you figure it out, you have a moat because it's hard. And it's also very challenging. So like, your day-to-day is not very easy for most people can't solve the problem. It's probably like a better way of putting it. And so it's a tough one, but it's very fulfilling. And so for that reason, I actually think it wasn't that big of a risk. There's probably a reason why healthcare stands sort of behind many of the technological advances that happen in other industries. And it's sort of the burden of people who choose this field to sort through that and make that potential that technology could bring to make people healthier possible. And so for that, it's a very fulfilling journey. And yeah, so not a risk as much as it is just a challenge.
I really sort of resonate a little bit with Ranjani's pathway a little bit, because I don't think my pathway was as circuitous, but it was pretty circuitous. And I feel like taking even sort of the decision to go fully into medicine and do the combined MD PhD training where you get trained as like a physician engineer, that was a big sort of leap on my part. I had been working at Epic for a couple of years, and I left because I was like, well, I think there's some interesting stuff we can do with the healthcare data that exists out there, and we can build amazing potential AI ML tools. But there's a big barrier between where we are right now and getting these tools into use. And I was trying to figure out, like, how do I build a meaningful career in this space? And the thing that I kept coming back to was, one, a technical understanding of the system, but then also a deep understanding of the drivers around why technology fails, which is a lot of the decision making of individuals, so individual physicians, individual patients, but then systems, right? So the health systems, the policies within the health systems, and then sort of the higher level, what policies we have in states and in nations, and then even sort of higher than that. And what I ended up sort of grappling with and this time I was working as a data scientist and also doing my master's, that I was grappling with, like, do I go to med school or not, and sort of upend everything and maybe have to move across the country for this, was like, do I think this is going to be a valuable bet for the future? And ultimately, I really believed that, at the time it was data science was more of the word that was being used, and ML was a little bit more on its ascendancy, and then eventually we have AI as the sort of big branding term. I thought that this is where medicine needs to go, and even if I don't necessarily, I don't figure it out and it doesn't totally work out for me, I will have tried to bring engineering into the field in the way that I think it needs to be done. So I thought it was worthwhile to sort of push and do that. And so I ended up at 28, moving to Michigan and doing this combined MD PhD for 8 years, which was quite disruptive, trying to set up a family and everything. But I think, as Chris has mentioned and as Ranjani has mentioned, like, being actually able to have that engineering perspective embedded into medicine is incredibly valuable, but you need to sort of do the necessary steps in order to understand, like, what are the problems and what are the barriers to implementing solutions in medicine. And you have to do a little bit more than your colleagues in other industries to be able to take that on.
Great. I really appreciate how all three of you took some risks, bet on yourself, but really did that with this vision of having the impact that you wanted to make in your careers. We have a room full of students here and like 2 professors, so 2 awesome professors who showed up today. But a lot of the students they're here, they have some time with us. And what advice would you have for them? For them either pursuing careers in healthcare or taking big risks?
On the healthcare, on the healthcare piece of that, I think one of the interesting lessons I learned on my career is that, and you learn this in school, and maybe over time, the skill becomes, I don't know, less honed, but you got to keep learning, and in technology, bringing it to healthcare, it's like this constant situation where you're with this team. And I remember this early in my career. There was, the Apple iPhone came out, and I was working on a medical device, and we were changing the user interface from like what was like files and folders and a comm wheel to a touch user interface. And I remember I was the only one that had the new iPhone. And I remember ripping off the usability features of the iPhone and incorporating our design into this med device. And it was because it was so beautifully done on the iPhone that translated incredibly well, because we were working on an anesthesia delivery device, and being able to the buyer was the anesthesiologist, was also the user, which is, again, as I said earlier, is rare, or sometimes rare in healthcare. And so if I made the user interface great, I was likely to beat the competition. And we, in essence, took aspects of that technology and brought it to this problem, and that ended up being wildly successful. And my point of that story is to say there's always sort of something new that someone else isn't curious enough to go learn, or they've got their whatever expertise, and now there's like a new transformer-based AI architecture, and they were the expert in deep learning, or some older part of the field. And that's always an opportunity for you to sort of jump in and go from new to expert very quickly. And then you become the expert on this niche thing, and people come to you, and you get to work on or incorporating that expertise into the sort of next generation of product. And so I got lucky and sort of learned that early. And I'm 41 today, and I do it every single day, because it's a competitive advantage to be curious about what's coming out and how it might apply to your programs. And people that sort of get left behind, they run out of that energy.
Thank you.
I'd like to add some thoughts to what Erkin said before, in terms of engineers wanting to make an impact in healthcare. I feel that in my career, one of the important things that I feel that I always kept in mind was that you have to kind of remember who you're serving. A lot of times, we engineers want to build things, we look at cool technologies and say, hey, I'm sure this will solve X or Y or Z. Because it can solve it does not mean that it's a problem that physicians or patients want. And I think sometimes this has always been a bridging that I've had to do in my careers at Microsoft, then at a couple of startups that I worked later, and now again where I am. So really focusing on the customer is the number one important thing. I've built a lot of things for providers. Even now, that's what I do. The second most important thing that I feel that us engineers have to think about when we come into medicine is really understanding clinical workflow. Do not underestimate the importance of actually sitting in clinic. When my team, for the first 20, 25 people at Microsoft, I used to kind of make that an option for it, not an option, actually a requirement for them to actually go sit in clinic. If you're building an AI-assisted scribe that integrates into Epic and Cerner, you really need to see how physicians are engaging with the EHR on a day-to-day basis. So really understanding clinical workflow and knowing that whatever you build has to fit into their workflow is super important. When we built the first AI scribe, right? You had to kind of remember, there was data coming out of Epic's audit logs, etc., saying that, an average doctor spends 3 minutes with her patient. Erkin is an ER physician. We had papers talking about the number of clicks he had to do to prescribe Tylenol. So you really need to understand what their workflow is before you put something in that's supposed to help them. So understand the customer, understand the clinical workflow. You really cannot be disruptive in medicine. You have to integrate with patient care. And the third most important things I have always found, whether it's working in the United States or working in global health, is understanding the economics of healthcare. Erkin brought that up. When we built the first AI-assisted scribe, I built it for orthopedic surgery. And there was a reason for that. 16 patients within the first half day. You needed a human in the loop. It's only the 4 O's, Erkin, you know what I'm talking about, who had scribes who could be humans in the loop to actually ensure that the system was working as it needed to do. So then you had like a reimbursement model with which you can actually make this work. You need to understand the economics of healthcare. And it's the same thing now when I work in global health. Subscription services may work wonderfully in the United States. They do not work in low and middle income countries. No government is going to, do a subscription service on whatever it is, which is an AI on the edge product that you're building. So those are the three things I would say are super important. Think about who you're serving, really take the time to understand the clinical workflow and whether what you're building can actually integrate into the clinical workflow, and always keep the economics in mind. So
I think both Chris and Ranjani have encapsulated this space very nicely. The one thing that I don't want to belabor, but I think you guys bring a optimism, right? That many people may not, that are in the day-to-day of maybe clinical operations of medicine, or that go through a I'm not going to say just a medical training, but a traditional medical training, doesn't get an exposure to be able to see what different technology could do, how you can experiment with it, how you could make code that could make life better. So you have that optimism, you have that ability, you can bring that in. But I think the big thing that oftentimes turns away clinical partners is when it's not grounded in reality, right? So they have a very they have a reality, right? And it's very different than I think our perceived reality of clinical medicine sometimes. And so being able to say, I respect your reality. I'm gonna go into your space. I'm gonna see how you work, really understand it, and really try to understand your problem so I can understand the constraints on what I'm trying to bring to you. And so that partnership, I think, is really, really where you get a lot of magic to happen, but you need to understand the constraints. And I think it's also important to like bring the optimism too. Like it is like the stuff that we do is cool. It can solve big problems. It's just that it's not as easy as like, push button to deploy and then people can download from the app store, right? And there are places in medicine that you can do that, but you can't do that across the board. So you just need to understand what you're going after and what the realities are. And then you can bring the magic into it if you do the hard work to understand all that stuff.
Thank you. Those are such great answers. I'm so inspired, but I also feel like as a professor who makes students do the observing for their class projects, I feel a little bit like that's the right thing that we're doing here. And I do firmly believe that engineering is optimistic and very focused on the future. So today's students are tomorrow's professionals. Can you shed some light on what some of the healthcare challenges will be like 10 years from now? And maybe particularly talking about AI and how that may or may not be an opportunity for them.
I can go on first on this one. So I like to sort of view where we're at right now is like things have really just started to heat up in terms of AI and machine learning in medicine or healthcare. And so, if you look at most academic medical systems right now, if you go ask their leadership, how many machine learning or artificial intelligence models are you using in your clinical care? They're going to probably rattle off a small number that'd probably be in the 10-ish range. And what we need to probably go from is having 10 models to like 10,000 in the next decade, I would say, at least in places that are, the large academic medical centers. You think about like, what is a model even? Like, what does it mean? Like, what's it serving? Is it answering one clinical decision? Is it answering many? Is it supporting decision making? Is it supporting documentation? Is it doing multiple things? So when I say model, it just, you can say abstract, AI tool that's supporting some part of medicine in a hospital. And you can think of something like UW Hospital. And then you think about like global health or community hospital. Those are very different environments, have some similar problems, but what impacts their decision making is fundamentally different than the decision making that's made at a place like UW Health or like Mayo Clinic. And the fact that these institutions with a lot of resources have spent a lot of resources and have a small number of models going right now should be an indication of some of the challenges around taking a idea and actually getting it implemented into practice. It's taken a lot of work to get a small number of models into the clinical workflow at the patient's bedside. And so the real challenge that I think we're going to need all of you for is to think about, how do we scale? How do we take, all of the different clinical problems that could benefit from a data-driven decision-making approach or a transformer-based approach to documentation, and be able to actually scale it in the clinical setting. And that involves really good engineering. You need to understand what the problem is. You need to understand the constraint set. You need to understand how to evaluate and then monitor and modify these tools over the course of a long period of time. And then you need to have an understanding of who's actually paying for these tools? As a physician, I can benefit from these tools, or a patient, I could benefit from these tools, but that doesn't mean that I get to make the purchasing decision. Ranjani was talking about it, and Chris was talking about it as well. There's different people that are actually going to be paying for these things. And just because you're solving a clinician problem or a quality problem that is objectively better to use this thing, doesn't necessarily mean that it is going to be endorsed in terms of going up for a capital budget allotment in the next year. And so understanding, how do you move those levers? How do you prove that this thing is actually the right thing to do for both the patients and the mission of the organization and the balance sheet? All of those things, I think engineering does a phenomenal job at being able to quantify. And we need to figure out, we also need to take these things and scale them, right? So I think you all have these skills, and you'll be able to help solve this next set of problems, where we're going from this small handful of models to, thousands of models in the next decade, hopefully.
I mean, that was a really robust response. I think I will only add, and it's a tough question. I'd say, the patient sensors, and there's a lot of data collected on a patient routinely, and we transcribe that down to downstream processes. I'll give you an example, like a CT today is let's say a gigabyte or two of data, and it gets sent to the referring physician in a document with 6 words on it, in a format that is difficult to understand. And so that's wild. That it's a very lossy process. You've lost 2 gigs of data translated through a doc with 6 sentences. And so I think the sensors are getting better. We're a lab in the United States. We continue to work with next-gen sequencing and getting richer information about your DNA and RNA and proteomics, and that'll continue to improve. And the tests that are really expensive today will be incredibly cheap. It'll be a blood test instead of me having to sequence a biopsy from your tumor. Those are things that you can guess in the next 5 to 10 years that are going to exist. So you're going to have lots of very rich patient data, and you're going to want to get the highest potential out of that. And so in order to do that, you can't you not only have to store each of those events, like the CT and the let's say blood tests, but you also have to follow the patient and see what happens to him downstream. Because if we're talking about wanting to build AI and loads of models that predict the future, you're going to need those associations. And very few companies at the moment have done that. And so we're a company that does it. There are a few others. We need more of that. And you can see the challenges of storing patient data and these associations, and navigating that is to this ultimate promise that sort of every patient.
We might have lost you. Okay. Oh, we might need to just move on, and then Chris will hopefully rejoin us. This happens in like every call. There's always a little bit of a glitch, but it should be fine. Ranjani, do you want to talk about the future?
Yeah, I think we've been talking a bit about sensors, and we're talking to the engineering program here at Madison. What I'm finding is that so Erkin was saying that some of the challenges in global health versus the United States are a little different. I would agree wholeheartedly, but I actually see them converging in a few interesting ways. Across the board, I think physicians are wanting to diagnose patients earlier in their disease journey. Access to care is difficult, whether you live in an urban area and have stellar platinum health insurance, or you're in a rural area where you may be 50 miles away from the nearest clinic. So what I have found is that, over the last couple of years, I've had the privilege of talking about how we're using low-cost sensors with AI on the edge on, your sub $300 mobile device. You're carrying a computer in your hand these days, correct? And, we're doing some incredibly interesting work in cardiovascular disease detection earlier in the disease journey, antenatal care, etc. And I find that anytime I talk about some of these innovations that are being invested in, I'll always have someone from the audience ask me about whether or if these kinds of solutions are going to be deployed in the United States as well. Cardiovascular risk is a global problem. You need to find it earlier in the disease journey where therapeutic options are actually available. That is, you can give drugs to the patient so that you can kind of, slow down the progression of the disease. So I actually think that some of the interesting work being done in engineering on sensors, AI on the edge, etc., will soon have a lot of applicability globally, not just in places where access to care is difficult, but access to care can be difficult here in the United States as well. I think we all know that. So there's a lot of opportunity, and as Erkin spoke to this before, you really kind of have to think about whether you're solving an important problem. And as Chris said too, one of the big things that I too focus on is tracking patient outcomes. If an innovation you're putting into practice actually affects patient care, changes the course of what kind of therapeutics you may have to give to the patient, and ultimately, are you changing outcomes for the patient? So that's super important, and it's actually incredibly hard to do. It's much easier to think about surrogates and say, well, instead of looking at the outcome of the patients, I look at something else. And there are pitfalls in doing that.
Great. Chris, we lost you for a minute. I'm glad you're back. We are going to start taking questions from the audience, but Chris, if there's anything else you wanted to add.
I don't know where I lost you. I think I was talking for 20 minutes to nobody. That'll teach you to go to the office to get your Wi-Fi versus where I'm home. I have like redundancies all over the place. So apologies for that.
No problem. All right. Who wants to ask the first question?
Hi, thank you for sharing your experiences, and I think these are all like very valuable insights. I'm a first year PhD working on machine learning, and I guess I have two questions. The first one is if I'm working on more like core machine learning problems, but I have interest in going into healthcare eventually, would you, since I don't have any domain knowledge in like healthcare or medicine or biology, would that be like a problem in the future if I want to go into this section? If I don't have any projects related to any of these fields? And then the second question is, do you have some predictions, let's say in 5 years, what would be the frontier machine learning methods or models that the healthcare section would need it can be just a very high level prediction. Yeah, thank you.
You know, part of that was easy, and then it got hard really quick with your part B. Part A is for sure you don't need to have domain expertise. Most of our teams, we combine people with various expertise, and you work on similar problems. And so you have doctors and data scientists and data engineers and software developers, and they're all on the same project, working together. And so there's people that you can interact with, and sort of fill your domain gap. And sometimes even that beginner's mind picks up something that maybe someone who's been in the space for a bit, you know, made an assumption, and that assumption no longer is true anymore. And so there's sort of an advantage to bringing your perspective from another space to the field. On the prediction about the future, I think it's a tough one. I think healthcare always lags thoughtfully for the data problem is really and so it'll happen somewhere else, and it'll be interesting to see. I think we're being able, like right now, there's a big unlock because most of the data that exists on a patient, I told you, gets translated through these like documentation exercises that are largely unstructured. And so you'd have to, in the past, we'd have, abstractors read 300 pages of PDFs and try to put the interesting insights into columns so that our applications would work. Now that can happen instantaneously. So a number of real-time applications become possible today. And so then if I take that and I say, all right, that's happening in documentation today, you can imagine that happening in imaging tomorrow, in some of these lab data pipelines after that. And so I think the ability to leverage all of the patient like raw data is going to be very possible in the next 5 years, and the frameworks that you guys are all developing are going to make that possible to do in real time, which means you're going to be able to not talk about these insights in like a batch retrospective way, but be able to help patients in a real-time setting.
I think I'll just a couple quick comments because I think Chris did an awesome job. Beginner's mindset is awesome. I think just if you want to get into this space, try to find clinical collaborators or people that are interested with the clinical expertise, and then start a project, right? And you'll learn, you'll pick up, and you'll make mistakes, but that's totally fine. In terms of what the frontier is going to be in 5 years' time, it's like a little bit of like almost anybody's guess, and everyone's pretty valid right now. I think the amount of data that we have available today is incredible, and I'm hopeful that we'll be able to do more stuff where we have more of these data sources put together, more multimodal, and then across the longitudinal lifespan of people as well. And then I'm also very hopeful that we'll have more open source tools, and then be able to analyze and look at different people's models, and also hopefully more open data sets as well. So hopefully more openness and more longitudinal and also multimodal data. But who knows what the methods are going to be? I think they're going to be pretty fun.
Hello, guys. My name is David. I'm a third-year undergrad here at UW-Madison studying computer engineering. And I have a general question about, you guys talked a lot about using AI machine learning in the medical field. And I guess the first immediate thing that always comes to mind with that is hallucination and accuracy of these models in the field. So I guess, how have you guys encountered inaccuracy, hallucination? What are some ways you've seen, been able to combat that to deliver a better experience for both patients and physicians?
I can take that. Let me, as I mentioned, my background was in building one of the first AI scribes for physicians. Definitely, I mean, this was at a time when when we first started, the transformer-based systems were not as robust as they are right now, but still you had hallucinations and you would see that. So a couple of things. One is you always have a human in the loop. Even if you write a clinical note or you put in a set of differentials, let's say, the patient is coming in with a set of conditions that she's describing, even if you're, making a suggestion to the doctor, it's a suggestion. It's the doctor is in charge of whatever it is that he or she is going to do. So you have to have a human in the loop. We've tried all kinds of different things like, adjusting precision versus recall in what you do. So the way I would explain that is, take of the simple case where you and your patient, let's say you're a doctor, you're having a conversation with your patient. You may be a physician who says, I like to see the sum total of what I talk to my patient about. I don't want you to synthesize and summarize and tell me what's important. Give me more recall, tell me more what happened during the conversation that I had with my patient. Or you could be the kind of doctor who says, I've got the gist in my head on what was important when I talked to my patient. So you give me what you think is important, you as in the AI tool. So, you have to put levers in place such that it's personalized for the user. You have to have guardrails in place. We still saw hallucinations. We would call it out. And of course, ultimately, it's the doctor who has to kind of make a decision, the doctor or the provider who has to make a decision on whether or not she or he wants to use the suggestion that's being provided by the system. So I'm not one to think about autonomous systems right now, especially in provider or patient-facing tools. It's not quite there yet, in my opinion.
Yeah, I agree largely. I'd say, the way we combat that is you triangulate multiple data sources is a way to fix that. It's you have the model describe the sources of the information, and you check those. It's train of thought. There's this framework in all healthcare med device land where you do like a risk management analysis. And so you try to understand the benefits of whatever you're doing, and then what are the likely error cases. So let's just assume hallucinations is one, and what mitigations do you have in place? And so you usually take most of your applications through that. And if the risk is not that big because you've got a doctor in the loop as an example, and that's your risk mitigation, then that works. Or if the mistake isn't that big of a deal, it just caused someone to show up to the wrong appointment, you might be okay with that risk for the benefits. So there's a number of ways, but right now I think we assume that it's going to happen, and we put mitigations in place around those applications. But we do think there's ways to make it lessen the occurrence of it less and less, and that's usually by providing the model more and more relevant context.
I agree with everyone like in what they've said thus far. An interesting thing for you all as students, since you're all sort of, the future of the field, if you will, to think about is like one of the things that I struggle with when I'm have my physician hat on, right? Less of the engineering hat is, I want to use these tools. I want to have AI help me during my day, but I do feel like sometimes, and I totally, as being and having an engineering perspective, I recognize that I'm going to be the stopgap for some of these things. If I'm using these tools, I'm expected to check over what it has. The buck stops with me, if you will. But I think we're going to need to move in the future to a place where some of the liability and responsibility of these things needs to sort of be shared between both the physician and the tool or tool developer, if you will, because I think it's a place where the physician can't check every single decision that's going to be made by these things. When we move to a regime where we have, so many of these tools going. And so I think this is an interesting place for, people that are interested in, both technical analysis, but also policy, right? There's a big technical component here, but also we need to have policy. We need to think about new rules, new governance, and, how do you ensure a model, right? Like things like that, where we can't just put all the burden on the user, and the user could be the physician, could be the patient, could be the health system. I think right now that's okay because of the scale that we're at, but we're going to go to a place where the scale, that's not feasible. So another thing for you guys to think about and a challenge, that's sort of also an opportunity.
Our expertise today. Can we have a round of applause from the students? Thank you. This was incredibly valuable. I feel like I'm going to be a better professor preparing our students for tomorrow's workforce in healthcare and data and AI. Thank you so much.